Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi, Herman and Corin. So we've talked about smart homes on this podcast in a number of episodes. And as you know, redundancy and preparedness and backups are also some of our long-standing favorite topics here. And this is a particularly challenging one for smart home owners. And it's going to become as more and more of us start using smart home technologies like Home Assistant. And inevitably, stuff is going to go wrong. Servers are going to have, like mine did, a motherboard failure, or the Raspberry Pi is just going to stop working. Inevitably, we're going to run into those kind of situations. And especially if you want to avoid the approach of everything just being only controlled through a locked ecosystem app. And the problem with that happening in a smart home is that it can mean that you can't turn on your stuff. It can be literally, it's a ridiculous situation to find oneself in, but not that hard for it to actually come about. Now, sometimes a lot of smart switches, for example, still have buttons, but increasingly, and sometimes we're going to see that being phased out in manufacturing, and we already see it for some things, that you can only control it through a device. So my question, Herman and Corin, there is no really easy answer to this. I still think smart home tech is a great thing, but I had one thought that I'd like to run by you for how this could be actually done. So we have a concept in technology generally of decoupling risk, and I guess if you ask me for Home Assistant, you might know that despite the home server stuff, I'm mostly still self-hosting things because I haven't figured out a better way yet, or in some cases it's just prohibitively expensive to do it otherwise. But for Home Assistant, it's because I guess the design made sense to me, right? If it's controlling your home, it makes sense that it lives in the home. But it would be something that I'd be more than happy to have running in the cloud, where you have the actual, the orchestrator as such living in a data, professionally managed, whether it's AWS or DigitalOcean or Hetzner, whatever you like. You can get a cheap VPS that'll host pretty much everything you might want to deploy for not much money. Now, the issue is that for smart home, if we're talking about networks like Zigbee and the rest of them, we still need some local infrastructure to control them, to speak to them, to transmit data to them if they're controlled, and to receive information back from them. That's the fundamental data flow in a smart home. Home Assistant, however, from a security or redundancy standpoint, is kind of a bad design, I'm going to say, because it comes as a complete package. It bundles together your if you do it in the conventional way, your Zigbee Mosquito is going to come along for the ride. You're going to have Zigbee 2 MQTT. You're going to have Home Assistant, the UI, the front end. You're going to have the back end. And while that's a nice design and makes it less intimidating to start with, it also means that if it breaks or goes down or you lose it without any backup, everything goes down all in one go. So my idea was to create a smart home design in which only the bare minimum elements of this stack were actually hosted locally, which would be let's say, Zigbee 2 MQTT, Mosquito, and maybe something if you're using Matter and those radio networks, and to have essentially a relay or a local proxy. And Cloudflare Tunnel is the obvious option. It's a outstanding tool. Probably be done with Tailscale as well. And that your local smart home box, as it were, is relaying data up to the cloud, and that's where your actual front end and back end logic. So the brain is really in the cloud, and you've just got this box that's transmitting stuff locally. Now, the pitfalls of this design is we're going to be introducing latency by introducing a cloud requirement. But unlike using stuff like Tuya, it's at least our cloud. It's a self-hosted cloud. The benefits, if that box goes down, the Zigbee box, it's still down. The proxy box, if you want to call it that, but it might be less catastrophic in that we at least have the controller mechanism, the logic, the front end, all that stuff is still up, and we just need to figure out how to get the controller back online, and we just maybe need to focus on that as our backup surface. So Herman and Corin, that's my idea, that's my brainstorm for a more resilient Home Assistant design. I hate to introduce complication to things for no reason, but this is one where I feel like it could actually be a smarter way to deploy Home Assistant. But Home Assistant is not the only game in town. Do you know of any home automation projects that are leaning into this principle? And regarding the actual mechanics of it, what would you imagine would be required? And do you think that latency between, let's say, a VPS in, I don't know, Amsterdam or Frankfurt and Israel relaying back and forth, would that actually lead to perceptible or unacceptable decreases in responsiveness for whatever we're doing in the smart home? And that's really it, Herman and Corin. That's my idea for a more resilient smart home. What do you think? And would you be so kind as to provide an actual implementation pathway if you think it's viable?
Hey everyone, and welcome back to My Weird Prompts. I am Corn, and today we are diving into a topic that hits pretty close to home for anyone who has spent a long, frustrating weekend wrestling with a smart home setup that just will not behave. We have all been there. The lights do not trigger. The dashboard is unresponsive, and you are left wondering why you traded simple light switches for a complex web of silicon and code.
And I am Herman Poppleberry. It is great to be here. Today, we are talking about the inherent fragility of the modern smart home. Specifically, we are looking at what happens when you try to do everything the right way, self-hosted, local, and private, only to realize that local also means you have created a single point of failure right in your own living room.
Exactly. Today's prompt comes from Daniel, and it is a fascinating look at system architecture. Daniel is worried about the risk of running an entire home's intelligence on a single piece of hardware, like a Raspberry Pi or a small NUC. If that little board fails, or if the SD card decides to give up the ghost after too many database writes, your house essentially loses its mind. You cannot turn on the kitchen lights, the heating might not kick in when the sun goes down, and you are left standing in the dark with a very expensive, very silent paperweight.
It is the ultimate irony of the smart home movement, Corn. We spent the last decade fighting to get away from the big tech clouds, the Tuya, the smart things, the Nest ecosystems, because we wanted independence and privacy. We wanted our houses to work even if the internet went down. But in building these local fortresses, we have traded one type of vulnerability for another. Instead of a server farm in Virginia going down, it is a $5 power supply in your hallway that brings the whole thing crashing down.
Daniel is suggesting a really interesting middle ground. He calls it a decoupled design. The idea is that the core logic, the brain, the rules, the user interface lives on a professional cloud virtual private server, or VPS. Meanwhile, only the bare minimum connectivity hardware stays local at the house. It is like moving the brain to a secure bunker and just leaving the nervous system behind.
It is a sophisticated approach. It is not quite the corporate cloud model where you are at the mercy of a company's API or their decision to sunset a product. Since you own the VPS, you still have total control over the software. But you are leveraging enterprise-grade reliability. Herman, you have spent a lot of time thinking about system architecture and high availability. Does this decoupled brain approach actually solve the reliability problem, or are we just moving the goalposts?
That is the big question. In engineering, we often say that you do not really eliminate complexity or risk, you just move it around. But Daniel's idea has some real merit if you are looking at it from a hardware longevity perspective. Think about where your Home Assistant Yellow or your Raspberry Pi lives. It is probably in a closet, maybe getting a bit dusty, powered by a consumer-grade wart, and writing constantly to an SD card or a cheap SSD.
Compare that to a data center. A virtual private server at a place like Hetzner or DigitalOcean is running on redundant power, with backup generators, professional cooling, and enterprise-grade NVMe storage that is designed for millions of write cycles. It is never going to suffer from a corrupted file system because a power flicker happened at the wrong time. In the cloud, hardware failure is someone else's problem, and they usually solve it by migrating your instance to a new node before you even notice.
Right, and if the local proxy fails, the little device that actually talks to the Zigbee or Z-Wave radios, you can just swap that one component out. You do not have to rebuild your entire automation logic, reconfigure your dashboards, or try to remember how you set up that complex node Redflow 3 years ago. You just point the new proxy at the Cloud Brain and you are back online. But I am curious about the projects that already do this. Are there people actually running Home Assistant in the cloud and just piping the sensor data up from their houses in 2026?
There are definitely people doing it, though it remains a bit of a power user configuration. One of the most common ways people achieve this right now is through a custom component called Remote Home Assistant. It is available through the Home Assistant Community Store, or HACS. It allows one instance of Home Assistant to connect to another over a secure link. So, you could have a very lean, dumb instance running locally that just handles the hardware radios, and then a beefy instance on a VPS that does all the heavy lifting.
So, in that scenario, the local instance is basically just a sensor and switch aggregator? It is not making any decisions, it is just saying, hey, the motion sensor in the hallway was triggered, and then the cloud instance says, okay, I see that, now turn on the light bulb.
Precisely. And that leads us to the other major way people do this, which Daniel mentioned, Zigbee to MQTT. This is really the secret sauce for a decoupled design. For those who might not be familiar, Zigbee to MQTT takes the signals from your Zigbee devices, your Hue bulbs, your IKEA sensors, your Aqara buttons, and translates them into MQTT messages. MQTT is a very lightweight messaging protocol that has been the backbone of the Internet of Things for years.
And because it is just a stream of messages, it does not really care where the broker, the post office for those messages, is located. It could be in the next room, or it could be in a data center in Frankfurt or New York.
Exactly. You could have your local Zigbee coordinator, maybe a tiny little device like a Sonoff bridge, or a dedicated network-attached coordinator like the tubes. Z or the SLZ06 sending those MQTT messages over a secure tunnel to your cloud server. The cloud server runs the MQTT broker and the Home Assistant core. To Home Assistant, it looks like the devices are right there on the local network, even though they are hundreds or thousands of miles away.
Okay, but we have to talk about the elephant in the room here, which is the latency. This is the part that always makes me nervous. If I walk into a room and a motion sensor triggers, that signal has to travel from my house, across the public internet to a data center, get processed by the automation engine, and then a command has to travel all the way back to the light bulb in my ceiling. Herman, is that going to feel like a delay? Are we talking about a noticeable lag between the motion and the light?
This is where the physics and the networking get really interesting, and it is where a lot of people's intuition fails them. Most people assume that the internet is slow, but for small packets of data like a sensor trigger, the latency can be surprisingly low. We are talking about the speed of light through fiber optics. If you are in London and your VPS is in a London data center, your round-trip time might be 5 to 10 milliseconds. Even if you are in Jerusalem and your VPS is in a European data center, your round-trip time might be 60 to 80 milliseconds.
For context, what is the threshold for human perception? At what point does a light turning on feel slow or broken?
Generally, in the world of user interface design, anything under 100 milliseconds feels instantaneous to a human being. It feels like a physical connection. Between 100 and 200 milliseconds, you might notice a very slight hesitation, a sort of softness to the interaction, but it still feels acceptable. Once you get over 250 or 300 milliseconds, that is when the uncanny valley of home automation starts. You walk into the room, you wait a beat, you start to wonder if the sensor missed you, and then the light comes on. That is the frustration point.
So, if your internet connection is solid and you choose a data center that is geographically close to you, you are actually well within that window of perceived instantaneity. But what happens when the internet goes out? That seems like the biggest downside to Daniel's proposal. If my fiber line gets cut by a construction crew down the street, I cannot even turn my kitchen lights on.
That is the fundamental trade-off. You are trading hardware reliability for network reliability. In a traditional local-only setup, if your internet goes down, your house still works, but if your Pi fails, you are dead in the water. In Daniel's decoupled setup, if the internet goes down, the brain is severed from the body. Now, in 2026, many people would argue that their fiber internet connection is actually more reliable than a Raspberry Pi's SD card. In many urban areas, internet uptime is 4 nines, 99.99%, but it is definitely a risk you have to accept.
I wonder if there's a hybrid approach. Could you have a local failsafe? Maybe a very basic set of rules that live on the local proxy, so that even if the connection to the cloud is lost, the most important things still work?
You absolutely could, and this is where the design goes from good to great. If you use something like ESP Home or even certain features of Zigbee 2 MQTT, you can set up what we call direct binding. Zigbee binding allows a switch to talk directly to a bulb at the radio level without even needing a hub or a brain to mediate the conversation. So, if the cloud goes dark or the VPS is undergoing maintenance, the physical switches on your wall still work because they are talking directly to the lights. That would be the gold standard for this kind of architecture.
I love that. It is like having a reflex system in your body that works even if the brain is busy or disconnected. You pull your hand away from a hot stove before you even consciously realize it is hot, because the signal only had to go to your spinal cord and back. So the local proxy handles the reflexes, the critical must-work lights, and the cloud handles the complex logic, like the high-level automations, the energy monitoring, and the user interface.
That is a perfect analogy. And it addresses the wife approval factor or partner approval factor that is so critical in smart home design. If the internet goes out and the good morning routine doesn't run, it's a minor annoyance. If the internet goes out and the bathroom light doesn't turn on at 3 in the morning, it's a household crisis. Direct binding solves the crisis.
Daniel also asked about the mechanics of setting this up. If someone wanted to follow this implementation pathway today, where do they even start? It sounds like there are a lot of moving parts.
It is definitely a project for a Saturday afternoon, but the pathway is clearer than it used to be. Step 1 is the cloud side. You need a virtual private server. You do not need a monster machine. A basic instance with 2 gigabytes of RAM and 2 CPU cores is plenty for Home Assistant. You can get these for $5 or $10 a month from providers like Hetzner, DigitalOcean, or even the Oracle Cloud Free tier if you can snag an instance.
And I assume you would want to run everything in Docker to keep it clean.
Absolutely. Use Docker Compose. You would want a container for your MQTT broker, Mosquito is the industry standard, and a container for Home Assistant itself. But the most crucial part, the part that most people trip over, is the secure tunnel. You definitely do not want to just open up your MQTT broker to the entire public internet. That is a massive security risk. You are essentially leaving a door open for anyone to control your house.
Right, you need a private pipe.
Exactly. You would want to use an overlay network like Tailscale or a WireGuard VPN. Tailscale is particularly brilliant for this because it handles all the NAT traversal and the messy networking stuff for you. You install Tailscale on your VPS and on your local proxy device. Now, they both have a private IP address that only they can see. To the local proxy, the cloud broker looks like it is just another device on the local network. It is encrypted, it is secure, and it is very robust.
So, on the local side at your house, what do you actually need? If we are trying to avoid the single point of failure of a Raspberry Pi, what are we putting in its place?
You want a very thin, very stable client. You could still use a Raspberry Pi, but because it is doing so, little work just running Zigbee 2 MQTT and a Tailscale client, it is much less likely to overheat or crash. Even better, you could use a dedicated network coordinator. These are devices that have an Ethernet port and a Zigbee radio built in. They don't run a full operating system, they just bridge the Zigbee radio to your network. You point that coordinator at the tailscale IP of your VPS and you are done. No local computer required at all.
That is a game changer. That eliminates the SD card issue entirely because there is no SD card in a dedicated network coordinator. It is just firmware.
Precisely. And that brings us to the database. Home Assistant is very write-heavy. Every time a temperature sensor changes by 0.1 degrees, Home Assistant writes that to its database. On a Raspberry Pi, those constant writes are what eventually kill the SD card. By moving the database to the Cloud VPS, which uses enterprise SSDs and proper file systems like ZFS or XFS, you have basically eliminated the #1 cause of local smart home failure.
I am curious about the user interface aspect of this. Daniel mentioned hosting the UI in the cloud. Does that make the app or the web interface feel snappier because it is running on faster hardware? Or does the latency make it feel sluggish when you are trying to toggle a switch manually?
It is a bit of both, but mostly it is a massive upgrade. If you have ever tried to load a complex Home Assistant dashboard with 20 or 30 history graphs on a Raspberry Pi, you know it can be painful. The Pi's processor just struggles to pull all that data from the database and render it. On a VPS, that same dashboard will load almost instantly because the CPU and the disk I/O are so much faster.
So the snappiness of the interface actually improves, even if there is a tiny delay in the physical light turning on.
Exactly. Navigating through your logs, looking at your energy usage from last month, or configuring a new automation, all of that becomes a much smoother experience. And the latency for a manual toggle? If you are on a good connection, 60 milliseconds is less than the time it takes for the physical relay in the wall switch to click. You won't notice it.
It is interesting that we are seeing a shift back toward the cloud, but in a way that preserves user agency. We spent years telling people to get off the cloud because of privacy and reliability, and now we are saying, well, maybe your own personal cloud is actually the answer.
It is the evolution of the self-hosting movement. We started with host it in your house, and now we are moving toward host it on infrastructure you control, wherever that may be. It is about ownership of the data and the logic, not necessarily the physical location of the server. This is what some people call sovereign cloud. You are using the tools of the giant's data centers, high-speed fiber, virtualization, but you are the one who holds the encryption keys.
Let's talk about the specific projects again. You mentioned Remote Home Assistant and Zigbee, 2 MQTT. Are there any other emerging projects in 2026 that are designed with this decoupled architecture in mind?
We are starting to see more movement in the Matter and Thread space. Matter is designed to be local first, but the way it uses IPv6 means that, theoretically, a Matter-enabled device could communicate with a controller anywhere as long as there is a secure route. We are also seeing the rise of satellite projects. For example, the Home Assistant voice assistant the Year of the Voice stuff they did is built on this idea. You have a tiny cheap device with a microphone that does no processing. It just streams the audio to a beefier server that handles the speech, to text. It is the same philosophy, put the dumb hardware where you need it, and put the smart logic where it can be powerful and reliable.
I wonder if this approach would also make it easier to manage multiple properties. If you have a main house and maybe a small apartment or a vacation home, could you run both of them from a single cloud instance?
Absolutely. That is one of the biggest advantages. You could have one master Home Assistant instance in the cloud with two different Zigbee 2 MQTT proxies, one in each location. You could have a single dashboard that shows you the temperature in both houses, and you could even have automations that span both locations. For example, if you leave your main house, it could automatically turn down the heat in your vacation home if it knows you are not heading there. Or, if the security alarm goes off at the vacation home, all the lights in your main house could flash red.
That is a really powerful use case. But I have to ask about the cost. A Raspberry Pi is a one-time $50 investment. A VPS is a recurring monthly cost. Over 5 years, you're looking at $300 to $600. Does the reliability justify the price tag for the average user?
For the average user who just wants their lights to turn on when they walk in the room, probably not. A well-maintained local Pi with a high-end endurance SD card or an external SSD, is usually good enough. But for the power user, the person Daniel seems to be, the person who has hundreds of devices and complex automations that their family relies on every single day, that $5 or $10 a month is basically an insurance policy. It is the price of knowing that you will never have to spend a Saturday afternoon reflashing an operating system or trying to recover a corrupted database from a backup that might be 3 weeks old.
I think there is also a psychological component to it. There is a certain peace of mind that comes with knowing your system is running on professional infrastructure. It feels less like a hobbyist project and more like a utility, like your water or your electricity.
Exactly. And let's be honest, we have all had that moment where a guest is staying over and the smart home fails, and you feel like you have to apologize for your own house. Oh, sorry, the guest room light isn't working because the MQTT broker crashed. Moving to a more robust architecture reduces those moments of friction. It makes the technology invisible again, which is what a smart home should be.
So, if we were to map out a clear implementation pathway for Daniel or anyone else listening who wants to try this, what are the steps? Let's summarize.
Step 1. Choose your VPS provider and spin up a basic Linux server. Ubuntu or Debian are usually the easiest paths. Step 2. Set up Tailscale on both the VPS and your local hardware to create that secure private tunnel. Step 3. Use Docker Compose to install Mosquito and Home Assistant on the VPS. Step 4. Set up your local Zigbee 2MQTT instance, either on a small Pi or a dedicated network coordinator, and point it at the Tailscale IP of your cloud broker.
And step 5 would be the most important for reliability. Configure those local failsafes. Use Zigbee binding for your most critical lights and switches so that the nervous system can still function if the brain is temporarily unreachable.
Precisely. It is a more complex setup initially, but the long-term stability is arguably much higher. You are essentially building a private, secure version of the commercial smart home clouds. But you hold the keys, you own the data, and you decide when the updates happen.
I think it's also worth mentioning that this architecture makes it much easier to experiment. If you want to try out a different automation engine, like Node-RED or AppDaemon, you can just spin them up on your VPS alongside Home Assistant. You don't have to worry about running out of memory or CPU cycles on a tiny Raspberry Pi. You have the overhead to grow.
That is a great point. The scalability of a VPS is a huge advantage. If your system grows from 50 devices to 500, you don't have to buy new hardware and migrate everything. You just click a button in your cloud console to add more RAM or more CPU cores. It is a future-proof way to build.
You know, Herman, I think this really addresses a fundamental tension in the smart home community. We want the convenience and power of the cloud, but the privacy and control of local hosting. This decoupled approach feels like a very elegant way to have our cake and eat it too.
It really does. It is about taking the best parts of both worlds. You get the professional-grade reliability and ease of management of the cloud, but you maintain the data privacy and the open-source flexibility of a local system. It is a sophisticated way to manage what is becoming a very sophisticated part of our lives. Our homes are no longer just four walls and a roof. They are complex digital environments.
I'm curious if you think we'll see more official support for this. Could you imagine a future version of Home Assistant that has a Cloud Core mode built in, where it guides you through this process?
I would love to see that. Right now, it requires a fair bit of command line knowledge and an understanding of networking and VPNs. If the Home Assistant team or another project could productize this, maybe a Home Assistant Cloud Core that you can deploy with one click on a VPS, I think a lot of people would jump on it. The Nabu Casa team is already doing great work with their cloud remote access, so this feels like a natural extension of that philosophy.
It certainly feels like the logical next step as the ecosystem matures. We've moved past the can we make it work phase and into the how do we make it indestructible phase.
And that is exactly where we should be. Our homes are our most important spaces, and the technology that runs them should be as reliable as the plumbing or the electricity. You don't expect your toilet to stop flushing because a server in Virginia went down, and you shouldn't expect your lights to stop working because an SD card wore out.
Well, I think we have given Daniel a lot to chew on. It is a bold design, but with the right networking and some local failsafes, it seems like a very viable way to build a more resilient smart home in 2026.
I agree. It is a classic engineering trade-off, but for the right person, it is a very compelling one. I am actually tempted to move some of my own more critical automations to a VPS after this discussion. I've had one too many SD card failures in my time.
Oh no, here we go. Another weekend project for Herman Poppleberry. I can already hear the mechanical keyboard clicking from here.
Guilty as charged. But hey, if it means I never have to troubleshoot a corrupted database at 10 o'clock on a Tuesday night again, it is time well spent.
Fair enough. Well, this has been a fascinating look into the future of smart home architecture. Before we wrap up, I want to remind everyone that if you are enjoying these deep dives, please leave us a review on your favorite podcast app. It really does help other people discover the show and join the conversation.
It truly does. And if you have your own weird prompts or architectural ideas you want us to explore, you can always reach out. We love hearing how you all are pushing the boundaries of what this technology can do. Whether it is decoupled brains or local, only AI, we want to hear about it.
You can find us at myweirdprompts.com, where we have our full episode archive and a contact form. You can also email us directly at show@myweirdprompts.com. We are available on Spotify, Apple Podcasts, and pretty much everywhere else you get your audio fix.
And a big thanks to Daniel for sending in this prompt. It really forced us to think about the fundamental trade-offs we make when we build these systems. It is easy to get stuck in the local is always better mindset without considering the risks.
Absolutely. Thanks for listening to My Weird Prompts. We will be back soon with another exploration of the strange, the technical, and the fascinating.
Until next time, stay curious and keep building. Goodbye.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.